Hey Evan, thank you so much for doing the Unit 6 practice quiz. The idea behind this is really just to see what it feels like when we put all of this information together into one assessment, all those different topics into one, because what we've been doing so far is just taking them one at a time, like just adding fractions or just adding this or subtracting or whatever. And now it's like trying to mix that all up and just see how that works for you. So one of the things I noticed here was that the time spent on this assessment was 9 minutes and 35 seconds. So there are 32 problems on this assessment. So I feel like maybe we didn't spend as much time as would have liked to show me what you know. So that kind of like I love to know more about what you're good with and what you're still struggling with, and if you have if you rushed through this a little bit, which it feels like, because I don't even think I could take it in 9 minutes, then I'm not really able to see what it is you need help with, and that's my ultimate goal. So I'm going to go through a couple of things here. And then I would really like for you to make the corrections that we need to make and send those back. And the way that you can do that is to get a sheet of paper and do the problems on the sheet of paper and have somebody help you scan them and email them to me. Or you can scan it and email it to me, whatever you think works there. Okay, so let's talk a little bit about changing from an improper fraction to a mixed number. So I can see what you did here is you just took the 5 out front, like 53 over 6, and that, that's obviously not how this works. So we have to do 53 divided by 6, and we have to do some long division here. So we'll find out how many times 6 goes into 5, which 6 can't fit into 5. 6 into 53. That's going to be 6 times 8, and then minus the 48 here. And then we subtract, and we get 13 minus 8, which is 5. And because we're looking to do a mixed number here, we end up with 8 and 5 over 6. So that would be this one here. So if I complete the problem as we're talking, then you don't need to make it as a correction. But if I don't complete it, then I'll have you do that. So remember on how we get from a mixed number to an improper fraction. So we're kind of going the opposite way here. I think you just took the 3 and put it up here for 36, and what we actually need to do is, if we have 3 and 6 nines, we go kind of around like this, and we do 3 times 9 plus 6, and we get the numerator over 9. So 3 times 9 would be 27, and then plus 6 is 33. So that's how we would get that one. So did those first two for you factors of 606. You are missing something here. So I'll start kind of with how I kind of set it up, is I start with 1 and 606, and then I try 2. And 2 is there because this is going to be even, so 2 and something, I'll try that. And then I go 3, 4, 5, I just keep going until I get to the halfway point. So check that one and see which answer might be better. And how do we determine if something is prime, composite, or neither? Well, we see a prime number only would have the factors of 1 and 105. So this one is definitely not a prime number because it ends in 5, so it's going to be divisible by something else. So then let me know if that's composite or neither. So prime factorization, we do our prime factor trees. This is how I kind of set this up, do a little tree here. So I always start by dividing by 2. So I do 216 divided by 2, and let's see, what do we get? That's going to be 108, and then I keep going with 108. I can't divide anything else by 2, but then I, maybe divide by 2 again. I just keep going, dividing by 2 as many times as I can, and there's 54, and then divide by 2 again, and that gives me 27. Now, is 27 divided by 2, like, is that possible? It is not, because 27 is an odd number. So let's try 3. Is 27 divisible by 3? Yes, that goes in 9 there, and then 3 and 3. So if these are all the things being multiplied together, 2 times 2 times 2 times 3 times 3 times 3, what would be the correct answer here? What would be the final answer? So I'll let you take a look at that and let me know. Which of the following pairs consists of equivalent fractions? I can see here you just kind of like flip this stuff around here. What we want to do is we want to reduce each of these. There's 2 different ways. So method 1 is like this. You can do 9 over 24, and you can do 21 over 56, and you can reduce them. So we can divide the top and the bottom here by 3 just to start. Oops, that's supposed to be a division sign. Then by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. Let's see, what can we divide 21 and 56 by? I think 7. So I'm going to divide by 7, because this is going to give me 3. And divide this by 7. This is going to give me 8. Oh, well, if they both reduce to the same thing, then they are equivalent. So I kind of did that one for you there. And then method 2 is kind of like old school elementary school type thing, where we cross multiply. So we do this cool thing where we do 9 times 56, and yes, I'm using my calculator to do that. 9 times 56, that's 504, and then we cross multiply this way because we're just checking to see if the means are equal, and that's 504. So those would be equivalent. Okay, I'll show you an example with this one. If we do 3/4 equal to 4/5, and we cross multiply, this would give us 15, and this would give us 16, so those would not be. So just to kind of show you a way to do that. All right, let's take a look at 13. Which of the following is a true statement? So again, you want to get these to reduce. I'll try the second one here to kind of get it to be the same. So this is 16 and this is 8. If I want to make them both 16ths, then I can compare them more easily. So I can multiply the 8 by 2, which gives me 16, and 3 by 2, which gives me 6. So is 5 out of 16 greater than 6 out of 16? No, it's smaller. So try to get a common denominator and then compare them. Okay, so here, multiplying, simplify the answer if possible. It looks like you added the numerator and added the denominator. We're doing multiplication here. So we want to do top times top over bottom times bottom. And then we want to reduce. Okay, so I'll let you go ahead and do that one there. So there's 14. I forgot to circle 13 as well. Finish up 13. And then 16, first we need to change to an improper fraction, which you will recall from one of the problems up at the beginning there. So I'll do the first one for you. So 2 times 3 is 6, plus 2 is 8, so it's 8/3 times, and then change this one, and then again, do top times top. Let me just make sure that looks like a multiplication sign. Top times top, bottom times bottom, and reduce. Okay, so let's try that one. Let's take a look at 17. Oh gosh, I got really small. All right. It says a company has budgeted 5 1/3 hours to complete a project with 1/4 of the time spent on research. How much time does the company plan to spend on research? Express your answer as a mixed number. So let's see, a company, this is the total hours of the project. Okay, this is the total. And they want to do 1/4 of the total on research. So this is kind of hard to think about sometimes with like the way these numbers are written. So sometimes I'll say, okay, let me change the problem here. Let me say it takes 20 hours to complete a project. It's 20 hours. And then I want to spend 1/4 of that time on research. Well, what is a quarter of 20 hours? Well, it would just be dividing 24 by 4, which gives us 5, and or just doing 20 times 1/4. So if I kind of know that, then I can say, okay, well, 5 1/3 then times 1/4. And then we would need to change this to a mixed number. So 3 times 5 is 15, plus 1 is 16. So 16/3 times 1/4. And then you're going to do top times top, bottom times bottom, and reduce. So you can finish that one. What is the reciprocal? Reciprocal just means flip the numerator and denominator. But in order to do that, we have to have it as an improper fraction first. So improper, 2 times 8 gives us 16, plus 3 gives us 19 over 8. And then we have to flip the numerator and denominator, which gives us 8 over 19. So you always have to make it improper first. And then flip that. Okay. Division. So division is keep, change, flip. So what do? We keep 3/4. We change the division sign to multiplication, and we multiply by the reciprocal of 9 over 14, which is 14 over 9. So keep the first one, change this to the multiplication, and flip this one. So then you know how to do 3/4 times 14, 9, so you have to top times top, bottom times bottom, and reduce. So I'll let you finish that one. Let's see with this one. You do this one too. Just remembering that you want to change to improper first. And then you'll do your keep, change, and flip. And then just your multiplication. Same thing here. We want to change this to improper, the first one to improper. And remember, all whole numbers are over a 1. So this is actually the fraction 2 over 1. So improper, and then keep, change, flip. Again. Okay, let's take a look at this. The lottery has a grand prize of $23.5 million. I could use $23.5 million. How about you? There are 5 people who have winning tickets, and they share the prize equally. How many millions of dollars does each person get? Well, what are we doing? We're taking 23 and 1/2, and we're splitting it or dividing it into 5 people. So again, you're going to change everything to improper, and then you're going to keep, change, and flip. So remember, this is always 5 over 1, so you can do that. And then this one here, oh, what happens here? Okay, so when we do fractions, we keep the denominator. So here's 8/9 plus 7/9. So we want a total of what is 8 plus 7/9, and that is 15/9, but they want it as a mixed number. But first I'm going to reduce. The top and the bottom can both be divided by 3. So that's going to give me 5 in the numerator and 3 in the denominator. Well, how many times does 3 go into 5? Once. And how much is left over? 2. So I kind of did that one for you. Rewrite these fractions with the least common denominator. So what you want to do is you want to write the multiples of 4 and 14 and see the smallest one that they have in common. So if you start counting by 4s, you count 4, 8, 12, 16, and you're going to need to keep going. And then 14, and then we have to add it to another 14, so it's 28. Another one is 42. I don't know that you'd have to keep going as much. I focus on the smaller one, try to see where the smaller one matches this one. So once you get them to be the same, which I think you may have here with the 28, that's correct. But remember, if you're going to change 3/4 to something over 28, you have to think of what did you do to the 4? Well, you multiplied it by 7, so you also have to do that to the numerator. Okay, So I'll let you finish 25.